Hey there, in this lecture I'm going to cover a couple of topics to do with the human biology, and I'm going to relate them to the machine design. So the first one is Alzheimer's, and this is a pretty well known illness that strikes down a lot of people, and basically they lose their memories in middle age and later. It's quite debilitating. So this one is not that well understood in terms of why it happens. They do understand that they do see certain proteins building up in the brain, and then the neurons die off, um, and then the person loses their memories. So, in terms of an Android design, this appears to be related to a timing issue in terms of the proteins. The neurons seem to shut down prematurely, and obviously that's not a good thing in a human being if our memories are how we kind of know how to solve problems and we recognize our loved ones and so on. So it's pretty important in an Android design that we make sure that the cells which contain the memories or the message stories don't die off. So we should employ some kind of mechanism to make copies of the data that we store, the message stories. Maybe in the future, maybe there will be techniques where people's memories can be scanned and stored somewhere and restored, but that's more science fiction at the time of writing. It seems to be related to chromosome 21. People with chromosome 21, two chromosomes, have a higher production of this protein. So the idea would be that there's some kind of epigenetic markers which seem to speed up the aging of the neurons, but that's just conjecture on my part. Next, I'll talk about synesthesia. This is really important in the design. Like, say, a human being might say it's a bitter wind as a statement, and it's a metaphor. But what we're actually doing there is we're mixing message types. We're mixing taste messaging with skin messaging, saying bitter wind. So one of the things that is asked a lot in evolutionary biology is how is it that say a human being is more evolved than say a primate? Because when they look at the actual physiology of a primate, there isn't that much of a difference. A primate can theoretically speak, and yet a human being can speak, but a primate can't. So, according to this theory, one of the evolutionary advantages we have over the other life forms that share our DNA, our chromosomes, is our messaging system is more advanced in that it has, at a genetic level, we pair message types. In other words, we have what's called synesthesia. It's the medical term, and the simple example would be the movie industry, how it evolved. It started with moving pictures and no sound, and then the words were in some kind of a card format. So you'd watch the movie, and then the dialogue would come on a card, and the movies were in black and white. And then over time, somebody invented an audio system, and they paired the audio with the video, and then suddenly you have kind of modern movies, the talkies as they called it. So our brains are naturally support the talkies. In other words, we pair sound and vision automatically within our brains, and we also support color through our color vision when it works properly, and we also support three-dimensional processing, which I'll talk about later. And that's one of the new innovations in the movie industry, is this three-dimensionality. And essentially where the movie industry is kind of moving is trying to support the brain architecture, which is what we do. We have vision, we have sound prepared with it, and we have 3D, and we have color, and we have widescreen. We have two eyes that create this widescreen view of the world, and that's what the movie theaters tend to want to produce, and it works, and people go to see it, and it's very enjoyable. But in a more kind of holistic view, um, the brain architecture is more about pairing message types. So, for example, some very accomplished musicians are able to pair uh, emotions and stories with songs. So, you have the lyrics of a song, you have you have the lyrics with the music. So there's a pairing that going on there, pairing sound with with words, and that's essentially music. It's more sophisticated than that, sure, but the idea is that we're pairing things, we're pairing up different message types. It's really important because this is, according to this theory, how we learned how to speak. We paired our vocal cords with our hosel, and then suddenly we have this wide range of expressive information that we can share with other people. Very, very important. So this is actually according to this theory, and this is key to the android theory, the thinking machine theory. The key is to combine message types in such a way as to give one an evolutionary advantage. And clearly, there's some message types you don't want to have happen, and then others you do, and I talk about that in the document. But the ones that work have improved our lives immeasurably. Now, I talk about migraine and system consciousness blockages. So, when we move away from the idea of pairing the messages to basically processing them in an efficient way, and some people suffer migraine, some people suffer these flashes of light, these visual migraines, some people have pain, some people have different, some people just can't function, so they're migrainers as they're called. So the idea would be that it's real important that the system consciousness, the analogy is the toll booth analogy, where the toll booth is system consciousness. It's got all these lanes and all these different message types. Some of the toll booths pair messages. Some of them are higher priority toll booth messages than others. Like being chased by a tiger message that gets processed immediately, and you start running whatever. And then there's other ones like sound and vision and all that good stuff. So what happens in a migrainer, according to this theory, is that all blocks up. Either there's a problem at the toll booth, which is the system consciousness part of the brain, or the messages are coming in too fast on a particular topic. So so it's real important that the messages are balanced with the system consciousness, using some kind of a queuing theory slash toll booth analogy, and that's it. It's real important that. So we want to make sure that a android or a thinking machine has, and I would argue that part of the system needs to be actively monitored for speed and performance issues, and our brain really works hard to get that right for people who are deemed healthy. Otherwise, you end up in this very debilitated migrainer state, I think. Now, the other thing I want to talk about in this lecture is the idea of weight, and how does the body maintain a particular weight. So the approach one takes, if it's just taking kind of a messaging approach, is there's two kinds of messages that go through the SC. So all messages are actionable. So in other words, if a message comes in that says eat, then the brain sends that to the region of the body which figures out what am I going to eat. And then if you get a message that says don't eat, well, then you're going to say to someone, if they offer you food, no thanks, I'm full, right? So it's a pretty simple design. It's a very complicated topic because it's food, of course, is obviously to do with how we maintain our stay alive, basically. So it's a kind of our body highly prioritizes eat and don't eat messages because it's how we function. So there's a lot of stuff, a lot of good stuff out there, that it's so important to exercise and to stay healthy, and to eat well, and all that good stuff. And then of course there's issues of obesity in modern Western societies, and they're all been dealt with a good kind of education programs to encourage people to conduct good lifestyles. But at the end of the day, the body, the system consciousness, rules the body in a very strong way. It's a very high priority message. So, although one may desire to lose weight, um, it's all about these messages according to this theory. So it's not that you can't lose weight, and it's not that you can't diet. It's more that one operates according to this theory within some kind of a weight range. So according to, and I'm not saying this is technically right. I mean, you may find research that disproves this, but if I'm applying a design pattern to an Android, this is what I think would make sense. That the Android has some upper and lower weight range, but a bit like a person, and that the being monitors its own energy levels, whether it be through insulin or uh, fat cells or whatever. They 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 message with this. Uh, they message with leptin, or I think it's a hormone, a leptin that goes into the blood, and it tells the body how much um, leptin there is. In other words, the fat cells say to the body, "There's so many of us here." So one imagines a human being having an upper weight range and a lower weight range. Now, the advantage of this design approach is, if this is true, it might explain why, for example, some people are more obese than others, and some people, for example, might suffer from chronic eating disorders. So, if one has an upper weight range, which is too high, one will continually receive eat messages from the body. Yeah. So this is the idea. The idea is a human being, according to this theory. I'm not saying this is right. This is just a theory. Okay. So there may be information to disprove this. But if, let's just say, we have an upper weight range and a lower weight range. If we have an upper weight range, which is like way off the scale, well, then the brain will message the body, eat, 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 and the person will eat, because it's a very high prior message. Unless one really, 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 really has the ability to overwrite those messages. But a human being won't be able, according to this theory, you won't be able to easily overwrite the message that says eat, because it's such a high prior message. In other words, a survival message. Now, on the other side, if you have someone with an incredibly low weight range, and they decide to lose weight, then they won't get the messages, and they just won't eat. They'll sit there and they won't eat, and it will be distressing for people to watch them. The healthy person will say, "Will you just eat something?" And they won't be getting the message, and they won't want to eat. According to this theory, so it requires a strong degree of re-education, and trying to make people appreciate foods. But the idea, according to this theory, would be, if this theory is right, is that it'd be good to find the part of the DNA where this upper and lower weight ranges are defined, so people won't eat too much, and they'll end up in a healthy weight range. This is not BMI idea. It would be interesting if research could find where this eat don't eat was. It'd be nice if it was found and it did exist. You might be able to tweak someone's upper and lower weight ranges in their genetically, so that they wouldn't suffer from these conditions. This would have to be done with experimentation. Like I said, I'm not saying this is 100% proved. This is just a theory, but let's just apply that idea to a thinking machine. One imagines a machine that might carry a load. Like I've seen. I think Boston Scientific do these running kind of dogs or lions or something. They're running machines, which are used to carry load from one place to another. So the idea would be that you build in, if they did build some kind of a messaging system into it, you would have a upper and lower weight range for the thinking machine in question, and you'd say the load this being can take it's in its upper weight range, so no more load, please, thank you very much. Um, you may put on battery packs or something and say, okay, no more energy, please. I'm at my upper energy level, my upper weight range. So having upper weight range, so it would be good for an Android to know its current weight, upper and lower weight, its energy reserves, and its backup energy reserves. And finally, and last but not least, I want to talk about dyslexia and locale specific learning. Now, this is really important. Again, it's that people have often, you might say, somebody has dyslexia, and it sounds like an illness, but what is it according to this theory? Basically, what people find hard to understand is it doesn't affect your IQ. In other words, some of the people who run billion-dollar companies are dyslexic, and yet they have dyslexia and they can't maybe read a particular document, or they can't efficiently, or they can't write a symbol, or they just don't understand stuff that, you know, certain people find easier in an educational environment. So the idea is pretty simple. You have your HOSL, which is your OS language messaging, and that is your core IQ. In other words, independent of the language that you learn, the symbols and the speech that you use, your underlying yeah, well, it's mostly visual and whatever, but it could be to do with your speech. You could be incredibly intelligent, but you just have trouble mapping to the locale. So in other words, your underlying HOSL is really high, quite high, but you have trouble with the symbology and the kind of the locale information. Maybe you don't get the letters, you know, the lettering system or the numbering system or the documentation type systems that are around, but your underlying OSL is spot on. So, like I said, you have some people in there, like the richest people in the world, and you talk to them and they say, "Yeah, I've got dyslexia," and you're like, "How do you, you know?" So the idea is that they don't the mapping mechanisms are slightly faulty in their brains, but their actual core ability to build a company, grow products, all that good stuff, it's there because it's in the underlying ability of the individual. So you got to so this is so then we then see that learn that the learning is uh, is basically related to the mapping of the hustle to the locale, and that's what we say when we're learning stuff, and that's what it's going to school and learning these things. It's about mapping things from your hustle to your locale. You know, whether it's the alphabet or it's the numbering system or it's you know, the various things that are unique to your country. You know, you might find in one country they, you know, people maybe are expected to do certain tasks more than in other countries, and a lot of the time that might be just that the underlying hustle, the people who live there have that natural ability, so it develops more in that region. But it all comes from the underlying hustle, the underlying genetic ability of the people. That's it. That's it for now. I just wanted to map these ideas. So clearly, we want the Android to have a learning mechanism and be able to map information efficiently and not suffer from a form of dyslexia. Next, I'll talk about spinning movement of balance, but not in this lecture.